Okay, so good morning, good afternoon, everyone. Voice is clear now. Haritha, Syab, Rakesh. Today, in fact, last lecture of hydrogen chapter we are having. So we will try to finish it. We have already completed so many things. Test was also there. Good afternoon. Kavitha, Kitty, Kusma. The session is live on YouTube as well as the app. Okay. Exam till now they have not said anything. I think it will be next week only. I think now. Okay. Less chances this week. Let's see if they inform you. So these minerals are only cations and anions. Amrut, these minerals are only, we are talking about cations and anions. Metal cations, non-metal anions are there. So we are talking about these only. We have to start with industrial method, Jameer. Okay, that only I'm saying less chances of exam this week. Okay, so hope everything is good. You are doing great. Taking a study nicely. It is raining everywhere. At your places also? Okay. Chalo, so we have to continue with preparation, and in preparation we were writing the third method. Okay. So we started with preparation. Which was the first point? Do you remember? First point was I think like this: ki acidification of barium peroxide. It's sunny. Okay. So weather will keep on changing, but our target should not change. ठीक है ना? So we have studied this. Barium peroxide was there, and barium peroxide we were doing acidification. So you can add H2SO4 as in NCERT. You can add phosphoric acid also. So H2O2 is the product. Second method was there. What was the second method? Do you remember? Hydrolysis of peroxodisulfate. Second method was hydrolysis of peroxodisulfate. ठीक है ना? And this peroxodisulfate was obtained by oxidation of sulfate, a bit acidified. So there was one question I was saying. You remember the second point? Listen, one point. We were saying hydrolysis of peroxodisulfate, and how you got peroxodisulfate? By oxidation of sulfate, or you can say dilute H2SO4. Don't use concentrated H2SO4. One question was there कि during preparation of H2O2 we do electrolysis of, and two options were there. One was dilute H2SO4 and the other one was concentrated H2SO4. Both are different things. We have said this before also, if you are having concentrated H2SO4, that it has two properties. One is dehydrating agent, and the second one, it is a strong oxidizing agent also. So you want to oxidize H2SO4 and it is itself oxidizing agent, so it is very difficult. So we have to use dilute H2SO4. So hope this is clear. Rest people, those who are new, I told you to just subscribe the channel so that you are able to get the notification, because class timing can be different. Okay. So let's start with the third point now. The third, that was lab preparation also. Do you remember? That was lab preparation of D2O2. From peroxodisulfate, that was lab preparation of D2O2. Hope you all remember these things. Clear? Okay. So let's start with the next thing, that is your industrial preparation. Okay, na? What we are having? Industrial. Spider is there. Spider is walking on this, so the things are changing. So industrial preparation of H2O2. So they have used one name of a compound. Okay, we should also know only the name because the compound is very big. I will write the structure also, but mainly we should remember the thing ki what is happening. So they have said ki auto oxidation. Auto oxidation means what? It will get oxidized on its own. It will get oxidized on its own. So auto oxidation of 2-alkyl 2-alkyl anthraquinol. So in NCERT next they are writing something like this ki I will take 2-ethyl. Alkyl is there, so you can use anything, methyl, ethyl, your choice. So 2-ethyl anthraquinol, and then they are saying self oxidation means it will take oxygen from the atmosphere, ठीक है ना, and it can get oxidized to H2O2. And in NCERT they have written oxidized product, means they are not interested in the oxidized product what is formed, they are mainly interested in H2O2. Now if you will see somewhere else, then they will make the diagram also. Acha, what is the diagram of 2-ethyl anthraquinol? So this is the diagram, big diagram will be there like this. OH is there, here also OH is there, color is same, change the color, and this is your 2-ethyl. Acha, if you will oxidize it, what will happen? O2. Oxidize it, it will get oxidized to this compound. Quinol is oxidized to quinone. Quinol is oxidized to quinone, in which no one is interested. No one is interested in this compound. Everyone is interested in H2O2. Clear with this point? So see, alcohol on oxidation, it is giving ketone. If you do reverse, means reduction, then you will get back to the original product. So for reduction, we know we can use catalytic hydrogenation. Okay, na? So this one is your 2-ethyl anthraquinol. Name is written only. Here I am writing the name. This can be said 2-ethyl anthraquinone, you can say. Okay, na? But no one is interested. Again, I am saying you because not written in NCERT. Okay, na? But then also be prepared what they are asking. Achha, now what they are saying ki the H2O2 obtained here is only 1% concentrated. The H2O2 obtained here is only 1% concentrated. Means what? Ki 99% is water or other compounds, you can say. Got this point? Means suppose you have 100 ml of the solution, 1 ml is H2O2, 99 ml is something else. Okay? So not beneficial, this means. So they are concentrating this. Okay, na? We can concentrate H2O2 to 30% by, this point is important now. How we can concentrate? This point is important. What they are writing, listen carefully, very important. Distillation at reduced pressure. Very important. When you will study, if you remember class 11, so NCERT only. Whatever is in NCERT, we have to follow that at least for NEET. Okay? So I am quoting the words of NCERT exactly, what is written there. Okay? They are saying no test this week, I think. Okay? So it is distillation under reduced pressure. Distillation at reduced pressure. Now what is this thing? Listen carefully. When you will go in class 11, some basic concept of organic chemistry, there are methods of qualitative and quantitative. Before that, there is purification. In purification, there are different techniques. In that technique, there is distillation. Now in distillation, there is variety. Steam distillation, distillation under reduced pressure, fractional distillation, simple distillation, many things are there. Okay, application is there. You can use this method this time. Okay, so similarly, there is one method, distillation under reduced pressure. Okay. Now there they will teach you. Now see, we are going beyond this chapter. So there they will teach you. Generally, distillation under reduced pressure is used for liquids having high boiling point. Now, for explanation, you can see that I'm just telling you what is written. Distillation is used for this distillation under reduced pressure is used for liquid having high boiling point. Clear? First point. Second point is also written there. Key or if the substance decomposes below its boiling point. So this is the case of H2O2. H2O2 will decompose below its boiling point. That's why they are doing distillation under reduced pressure. So those who are interested, now they can go and see it there. Hope this point is clear. So this point is very important, distillation under reduced pressure. Now they are saying again in NCERT from 30% I can reach to 85% also. By again same technique, distillation under reduced pressure. From 85 they are saying whatever water is there, now I will freeze that water into ice. Then you remove it. You are getting pure H2O2. You are getting pure H2O2. Is this point clear to everyone? Okay? So these things are written in NCERT. Chalo, theek hai, fine. Now come to, means you have to note this, ki I have to do distillation under reduced pressure because it will decompose below its boiling point. Clear? Okay. So now come to the next point. The next point which is written in NCERT is your physical properties. Physical properties, what they are writing, ki bhai it is almost colorless. Arey, what is this almost colorless thing? So you know na, you know water, pani, water is colorless, but it looks like blue. You say na, blue hai pani, pani. So what is happening here? Ki it is almost colorless. So what you will say ki in pure form, you can say in pure form almost colorless. They say like this, if large quantity is there na, then it looks very pale blue. In large quantity it looks, in large quantity it looks very, see the word used, very pale blue, means almost colorless they are saying. That's why they are using the word. Theek hai, no problem. Now there is also one very interesting thing in this. What is one very interesting thing in this, you know? You know concentration terms? Yes sir, I know. I have studied this in first chapter. 2 molar, 3 molar, 5 normal. They are using percentage weight by weight, percentage weight by volume. Do you remember all these points? Yes or no? Okay. Then what they say? Ki theek hai, mole fraction you know. So all these are concentration terms. But when you will go in the market or when you will go and check on the bottle of hydrogen peroxide, you will not find generally percentage weight by weight. They are not using molarity. They are not using a different types of term they are using. They are writing in terms of volume strength. They are writing in terms of volume strength. What will be written there? 10 volume H2O2. 20 volume H2O2. Now the fact is, what is this 10 volume, 20 volume H2O2? In fact, the commercial H2O2 is marketed as, means in the bottle, what you will write there? They will write ki 10 volume of H2O2. They will write what? 10 volume of H2O2, or they will write 3% of H2O2. The commercially available H2O2 is 10 volume or 3%. Remember this point. This point they will ask you. Ki commercially H2O2 is marketed as, what you will say in terms of percentage? Jaldi batao. And this percentage is in fact weight by volume. This percentage is in fact weight by volume. What you will say? What percentage you will say? 3%. What you will say? 3%. Okay, clear with this point? Acha, all of you have opened NCERT or not? Check it. In NCERT everything is written. NCERT is everything for us, especially in chemistry. Especially in chemistry. Clear with this point? Done? Okay, fine. Now what? Now the question arises, sir, what is this new term? I am seeing this for the first time. Before this, I was talking in terms of molarity. But what is this 10 volume, 20 volume, like this? So listen carefully. First of all, I will write a reaction, that is decomposition of H2O2. H2O2 decomposes to give H2O plus half O2. Can you see this reaction? This is decomposition of H2O2. Done? Okay. ठीक है. Now what do you mean by 10 volume? See what they say, 10 volume of H2O2 means, what it means, कि if you take 1 liter of H2O2, 1 liter of H2O2 gives 10 liter of oxygen at STP. This is the meaning. If they are writing here कि भाई this is 10 volume H2O2, means what, कि 1 liter of H2O2 will give 10 liter of oxygen at STP, will give 10 liter of oxygen at STP. This is the meaning. Are you getting this point? So similarly, if I ask you, everyone try to write this. If I ask you 20 volume of H2O2, what you will say? Everyone try to write this in the comment section. ठीक है ना? If I ask you 20 volume of H2O2, then what you will say? You have to write the full statement. If I say you कि I am having 20 volume H2O2, then what you will say? You will say कि 20 volume of H2O2 means, what you will say, 1 liter of H2O2 gives, what it gives, 20 liter of oxygen at STP. This is the meaning. ठीक है? Is this clear to everyone? If I say 50 volume of H2O2, then what you will say? If I say 50 volume of H2O2, then what you will say? 50 volume of H2O2. You will say कि 1 liter of H2O2 will give 50 liter of oxygen at STP. So is this point clear to everyone? ठीक है? Now, so ठीक है, now we have understood कि what is this volume strength. This is only known as volume strength, 20 volume, 10 volume. But you will say, sir, all the questions we are doing in molarity, this is given in volume strength. So is there any formula to convert volume strength into molarity? Yes, of course there is a formula. We have the derivation also, but ठीक है, derivation we can ignore for now and we can directly write the formula. See here, we can write the formula of molarity. Molarity is your volume strength divided by 11.2. We can directly write the formula now. We can derive it also, but derivation will take time. We have some time constraint also, and in NEET we can do by this also. Okay, fine. So molarity, those who are more interested, they can check it the derivation once. So molarity is what? Volume strength divided by 11.2. Acha, for learning I am telling you how you are getting this 11.2. You know that term 22.4, 22.4 divided by 2 is 11.2. From here we are getting this. Now why I am telling you this? Because in NCERT for this they have used the word 22.7. They have used the number 22.7. So if you go exact, it will be 22.7 by 2. But no one cares. Everywhere it is solved in terms of 22.4. Okay, so what will be the unit of this? Unit is mole per liter. Is this clear to everyone? Is this clear to everyone? So now you can tell, if I say 20 volume of H2O2, what is the molarity? Jaldi se batao. 10 volume of H2O2, what is the molarity? 30 volume of H2O2, what is the molarity? Is this clear to everyone? Jaldi, 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 quickly, Twarga. 20 by 11.2, 10 by 11.2. The last one is 30 by 11.2. Is this clear? देख लो एक बार. 30 by 11.2. Is this clear? So just check it once. Everyone just check it once. ठीक है? If I say 100 volume H2O2, then what you will write? 100 volume H2O2. Then what you will write? 100 by 11.2. Is it okay? After dividing, you will get this value 8.33 molar. So now everyone knows how to find molarity from volume strength, although we are using the formula directly, but you can find, I think. Oh, so is this clear to everyone? Okay, so you are having calculator also, you are telling direct value. Sir, this one is coming 1.7, this one is coming 0.8. Okay, very good. And then this one is something, this one is 8.33. Okay, clear? Why I am writing 8.33, I will tell you. Clear? So all of you know how to find molarity. If volume strength is given, all of you can find molarity. Now they are not satisfied with this also. They say ki, I don't want molarity. No? Did you see this point? Ki the commercially was marketed as 10 volume or 3%. So they will say, I want percentage. What I want? I want percentage. Now the question is that ki how to get percentage by? How to get percentage? Now keep this in mind. See, percentage means what they want, you know. They want gram per liter first, strength. Then we can convert into percentage. So listen carefully. Everyone listen carefully. First we are interested in strength. They will ask you strength of H2O2. When they say strength, this means they mean gram per liter. When they are saying strength, this means they mean gram per liter. Normality also you can write. Very good. If you are interested in normality, you can do normality like this. Normality, I am writing it also. You see it. Normality is volume strength by 5.6. Because you know this formula. Which formula you know? Ki bhai normality is molarity into N factor. N factor for H2O2 is 2. Is this clear? Is this clear? So once you have found molarity, normality is not difficult. Right? You will say, sir, I have studied mole concept. And if you have studied mole concept, means you can find molarity, normality. So this is the relation. Divide by 5.6. Half of this 11.2 divided by 2 is 5.6. Clear? Done? Is it okay? So we can find molarity, we can find normality. But my target is something else. My target is strength. Strength means what they mean? Gram per liter. Strength means what they mean? Gram per liter. So theek hai, how I can do this? Try to use your brains a bit. See, molarity is mole per liter. I want gram per liter. Are you able to see something? Molarity is mole per liter. Strength we are writing gram per liter. Means I can think quickly ki arey, if mole I convert into mass na, then I will get gram per liter. Mole, if I convert into mass, then I will get gram per liter. MK writing correct. He is telling ki sir, you multiply molarity by molar mass. What is the molar mass of H2O2? 34. Clear with this point? Is it okay? Strength in gram per liter. Gram per liter means what? Mole per liter ko convert. Mole into gram. So how you can convert? Multiplying by molar mass. What is the molar mass of H2O2? 34. So now I got gram per liter. Is it okay? Now they will say ki I don't want gram per liter also. I am asking you again and again, tell me percentage. Bolo bhai, how to get percentage? So simple. ठीक है, listen carefully. Percentage I told you na, they are asking weight by volume. So see, if I want percentage weight by volume, what I have to do? Listen carefully. Already this term is in gram. This I will convert into ml. 1 liter is 1000 ml. So see this point ki gram per liter value is there. Liter is there. I will multiply 1000. So what it will become? It will become ml. Are you getting this point? If liter is there, liter may I multiply 1000, I will get ml. Now to find percentage, I will multiply by 100. See, this value was gram per liter. So I will divide this value by 1000. So what I will get? Gram per ml. See this point quickly. M into 34. This is gram per liter. I will divide by 1000. Now this value is gram per ml. Gram per ml, to find percentage, I will multiply 100. So finally what I am getting, you know, ki if you multiply m into 3.4, you will get percentage. Or simple you can say, or what you can say, here no problem, you just divide strength by 10. So if you have 30% strength, if you have strength means what? Gram per liter. Okay, check this one once. If the strength is 30, that means percentage is 3%. ठीक है ना? So if you want to find percentage, very easy. Strength को just divide by 10. See here, 1000 na? How you are getting this? Everyone check it. 100, 10 left. So just divide strength by 10, you will get percentage. So we have derived 4 formula. Just now summarize everything quickly. You tell me quickly everything. What is molarity formula? Volume strength by 11.2. What is normality formula? Volume strength by 5.6. What is strength formula? Strength formula gram per liter. This is your molarity into 34. What is percentage weight by volume formula? No problem. Strength divided by 10. That's it. Simple. Very easy. Now come to NCERT. So NCERT question says, what is the percentage of? What is percentage of 10 volume of H2O2? So can you quickly find everything? Jaldi batao. Can you quickly find everything? 1%? Are you sure? So see, I can do like this. Here, very easy. Molarity is 10 by 11.2. And strength is your molarity into 34. Means 10 by 11.2 into 34. Are these two things clear to everyone? Check it out. Are these two things clear to everyone? Syam, are you sure it is 1%? Because as far as I remember, NCERT answer is 3%. ठीक है? So, are you sure? One boy more is writing 1%. Just check it. And before this also we have written now. Why you are writing 1%? Before this also we have written. Do you remember? H2O2 is commercially marketed as 10 volume. 10 volume is how much percentage? 3%. Is it okay? So from here I think you will get the value 30. Around 30. So percentage weight by volume is your 30 by 10, that is your 3%. Is it okay? So by seeing this now, I can do one more question very easily. 100 volume of H2O2. You can tell everything quickly. Arey sir, very easy. 100 volume is what? 30%. 100 volume is what? 30% of H2O2. Clear? So these two data you have to keep in mind because these two data are written in NCERT. So 10 volume is how much percentage? Jaldi batao, jaldi batao. 10 volume is how much percentage? 10 volume is how much percentage? So 10 volume is 3%. And 100 volume is 100 volume is 100 volume 100 volume is 30%. Clear? So these two things we have to know at least, and we know all the formula. Okay, we can directly, there is derivation also, but we can use the formula also. So hope everything is clear to everyone. Done? Done. Okay. So moving to the next part. So now we will directly come to few points which are in NCERT only. Numerical we have done. Volume strength we have understood. There is one more question, you know. There is a question like this. There is a compound perhydrol. You will study in the uses. Perhydrol is a compound which is 30% H2O2, which is 30% H2O2 perhydrol. So what are the correct options for this? 30% H2O2 means how much volume? 100 volume of H2O2. They will ask what is the molarity? 8.33 molar. The third option they will write both A and B. And D option is none of these. So in the uses you will find H2O2 use. We will come to that point quickly. Perhydrol is there a substance of H2O2 which is 30%. Okay, na? Weight by volume. So what are the other concentration terms? So we know if it is 30% means it is 100 volume. Okay, clear? 100 volume means 8.33 molar, and both A and B is the correct answer. D9, C. So we have said everything. 100 volume is 30% and 100 volume is 8.33 molar also. Now you know why I was writing the exact numbers. Okay? So 100 volume is 8.33 molar. Is it clear? Both A and B. Done. Now let's come to a few things which are directly in NCERT. So that part is my diagram. They will talk about structure. Everyone come to this page now. They will talk about structure. So we know this also. What we know, diagram of H2O2 or structure of H2O2 is open book like structure. What they say? Ki structure is open book like structure. O2F2 is also having same. Like O2F2 you can say. O2F2 is also having similar structure. Open book. Open book means what? Like this was your book, open it. So it has open book like structure. On this part you have OO. One O, second O. One hydrogen this side, one hydrogen this side. So this is a non-planar structure. Keep this in mind. It is a non-planar structure. Then can we say like this? Ki it has both polar as well as non-polar bonds. Can you say? It has polar as well as non-polar bonds. Clear with this point? Done. Is it okay? Are you able to understand? So these 3 points are there. So this is open book like structure. This is the lower portion of the book and this is the upper portion. On this you have one OH bond and on this you have a second OH bond. Okay? So it is non-planar. Okay? Clear? So they will ask you planar, non-planar. So it is non-planar structure. Now they have made 2 diagrams. One diagram is in gaseous phase and the other diagram is in solid phase. So this diagram is for gas and this diagram is for solid. ठीक है ना? What is their favorite question in this? The favorite question is dihedral angle. Favorite question is dihedral angle. What is a dihedral angle? Like suppose you open a book. Suppose you, I'm not having anything. You can think like this. I'm having an extra laptop here. ठीक है ना? See this point. Suppose this is my book. This is closed now. ठीक है ना? So I am opening it. I am trying to open it. Hope it does not fall. So I am opening it now. Can you see this? So this angle, this opening angle between the two plane is known as dihedral angle here. Although you study dihedral angle in conformations. Is it clear? Between two faces. They say between adjacent bond. Now I am opening it more. Now can you tell how much dihedral angle is there? How much dihedral angle is there? Can you tell? What is the dihedral angle now? 90 degree. Correct. What is the dihedral angle now? 90 degree. ठीक है. I am increasing a bit. When I am around 90, I am in solid phase. See, in solid phase, dihedral angle is 90 degree. So I am here. So what is? It is switched on also. ठीक है? Okay, no problem. See here. So what is happening now? One oxygen is here. One oxygen, second oxygen. One hydrogen is here. One OH bond. Second OH bond here. Is this clear? So one OH, second OH, OO. So this is solid case. So you can remember कि sir told solid diagram by opening the laptop. 90 degree was there, dihedral angle. Clear? ठीक है? So what we can say now, if gas is there, then you can say कि अरे if gas is there, then intermolecular forces will be weak. It will be opened a bit more. Now see it. Now you can say it is more than 90. So now we have reached in gas phase. So the angle is 111.5. Can you see the angle? Angle is 111.5. Let's decrease a bit. Clear with this point? So are you getting the dihedral angle concept? And you have seen the diagram also, it is non-planar. One bond is here, OH. Other bond is here, OH. O, O, OH, OH. Open book-like structure. Book is opening. Open book-like structure. So hope everything is clear now. Okay. Chalo, done. Now you have to remember, compare also. They will ask you to compare, where I kept the pen. Okay, they ask you to compare OO bond length. So see, if I say this bond length is X and this bond length is Y, then in which case bond length is more? In gas phase, bond length is also more, X greater than Y. OO bond length. Now see, if this bond length is more, that means this bond length is less. 95, here 98. So is this clear to everyone? So in gas phase, you can remember like this. In gas phase, dihedral angle is more, 111. Okay, approximately. And OO bond length is also more. If OO bond length is more, means OH bond length is less. Is this clear to everyone? All of you can compare. Is it okay? In gaseous phase, dihedral angle is more, 111, O bond length more, 147.5, OH bond length less. This bond length is more, this bond length is less. They can compare the inner angle also, but now that will be a problem. Because in learning so much, we'll forget the important thing only. I told you now what they will ask. First they will ask you dihedral angle. Acha, there is a very famous type of question they do. You will remember 111 and 90. You will say, sir, two datas I have remembered, 111 and 90. And you will forget, ki, it was in gas phase or solid phase. They will silently exchange there. they will write ki array in solid phase dihedral angle is 111 and in gas phase dihedral angle is 90. Is it true? What I just said, is it true? In solid phase dihedral angle is 111 and in gaseous phase dihedral angle is 90. Is it true? No. They have reversed the thing. Totally thing changed. So keep this in mind. So in gas, more angle and more O bond length. More O bond length. Okay. Come to the next point now. So before starting the next point, we can do one more thing. We will talk about chemical properties. We will talk about chemical properties. So what is the chemical property? You know कि H2O2 oxygen is present in -1 form. So it can act as both oxidizing agent as well as reducing agent. Keep this in mind. It can act as both oxidizing agent as well as reducing agent, because it has intermediate oxidation state. You know, oxygen can be in -1 also, oxygen can be in 0 also, oxygen can be in -2 also. So I'm writing like this, and 0 also. Here you can say if it is water, this, if it is oxygen, 0. So -1 is intermediate. So it can get oxidized also, it can get reduced also. So if you are converting this into oxygen, this part is oxidation. And if you convert this into water, this part is reduction. Is it clear? So they will say you first question, H2O2 can act only as oxidizing agent, true or false? H2O2 can act only as oxidizing agent, true or false? Say quickly. H2O2 can act as only oxidizing agent, true or false? False. It can act as both oxidizing as well as reducing agent. It can act as both oxidizing as well as reducing agent. It can act as both oxidizing as well as reducing agent, true. Correct? Okay? Why? Third question. Why H2O2 acts as both oxidizing as well as reducing agent? Why H2O2 acts as both oxidizing as well as reducing agent? See, I am telling you, benefit of this lecture will be only when you are regular. If you are coming one day, next day sleeping, coming next day, again sleeping, this will not help. Okay? Why? Why H2O2 acts as both oxidizing as well as reducing agent? So you will say because oxygen is present in intermediate oxidation state. It can be oxidized also, it can be reduced also. Clear with this point? Here 0, here -2. Achha, so can you tell me, in this case, it is acting as oxidizing agent or reducing agent? In the upper case, here it is acting as reducing agent and here it is acting as oxidizing agent. You know the definition now? There is no problem in definition? Correct. Surya, Kusuma, Kavita, Srikra. Okay. I pronounced correct? Sanjana, Haritha. Okay. Chalo, fine. So it can do both. And you know, this can be done in acidic as well as basic medium. Means medium, there is no problem. Means H2O2 can act as oxidizing agent and reducing agent in both medium, acidic as well as basic. So you can extend this line. It can act as both oxidizing agent as well as acidic reducing agent in both acidic as well as basic medium. Irrespective of medium, you can say. Acidic medium also, correct. Basic medium also correct in both mediums, in acidic medium also as well as in basic medium. So is this point clear to everyone? Now let's see some examples. Now let's see some examples. Like first time we are doing the reaction in acidic medium. We are doing the reaction in acidic medium. Okay, no problem. Okay, now see, I have written here a few things only. In NCERT, you will find balanced equation. In NCERT, you will find balanced equation. Balancing we study in redox chapter. So if you know balancing, you can balance these reactions, no problem. Okay, na? But what is the main question asked? Main question they ask कि which element or which ion is oxidized in which form, like you see here. Or they can give you a reaction like this and they will ask you कि H2O2 is acting as what? So you see here Fe3 2 plus is there and Fe3 plus is there. So this part is oxidation. H2O2 from -1 it is going to H2O -2. This one is your reduction. So H2O2 is acting as oxidizing agent. So they will ask you with H2O2, Fe2 plus is converted in which form? Tell quickly. Fe2 plus is converted into which form? So now we know here Fe2 plus can be oxidized to Fe3 plus and H2O2 is oxidizing agent also. So Fe2 plus is oxidized to Fe3 plus. So this is easy, everyone knows. Okay? So they will ask you a bit difficult part. Do you know what is the oxidation state of sulfur here? Can you tell oxidation state of sulfur here? Can you tell oxidation state of sulfur here? जल्दी बताओ त्वरगाचे पंडे. So you know कि sir, this is very easy. Lead sulfide. In sulfide, sulfur is present in -2 and here sulfur is present in +6. So I know what you know कि sir, this is oxidation. Clear with this point? So keep this in mind and reply this question. They will ask you, in acidic medium, sulfide is converted to dash. Sulfide is converted to dash by H2O2. In acidic medium, sulfide is converted to. In acidic medium, sulfide is converted to everyone write this. I want this answer from everyone. Those who are watching, everyone write the answer. In acidic medium, sulfide is converted to dash by H2O2. Okay, you can say black money to white money. PBS is black color. PBS is black color. ठीक है ना? So you get black to white. ठीक है ना? So sulfate, you are getting to PbSO4. You are getting PbSO4. PBS is black in color. You will you study this in that only. Test for sulfur. ठीक है? Clear with this point? Done. Okay. Now come to the next point. Reducing agent. We are talking about reducing agent. So how it is behaving? See here. Manganese is present in highest oxidation state, that is +7. It is reduced to +2. So this part is your reduction. Who is doing this? H2O2 reduces other and itself oxidized. I told you when H2O2 is converted into oxygen means it is acting as reducing agent. Clear? So MnO4 minus is reduced to Mn2 plus. See, this point is also important. This we study in D block. This we study in D block. Ki MnO4 minus is reduced to Mn2 plus. MnO4 minus is reduced to Mn2 plus in acidic medium. In different medium, different things happen. Like MnO4 minus is there, na? See, I am writing it here once. It is reduced to Mn2 plus acidic medium. it is reduced to MnO2. MnO2 means what? MnO2 means +4. In, they say, neutral medium, or they say feebly basic, slightly basic, and it is converted to MnO4 2 minus +6 in strongly basic. So you will study here KMnO4 is itself a very important compound. In D block you will come to know कि MnO4 is reduced to different form in different medium. We will see it here also. So see, in acidic medium from +7 to +2, what is the oxidation state of chlorine here? +1. From +1 it is reduced to -1, like this. So main important thing is who is reduced to which form, who is oxidized to which form. Okay? So from here we have seen sulfide is oxidized to sulfate, permanganate is oxidized to magnus ion, you can say Mn+2. This they were saying कि highly explosive type, oxygen gas is liberated ना, oxygen, ठीक है ना? So explosive type reaction is there, all the water will be vaporized, exothermic reaction is there, ठीक है? Okay, now come to the next part. Where is the next part? Okay, next part, now we are doing the same reactions in basic medium. So this reaction the same only, ठीक है ना? And this reaction is also same. These two reactions are same. See, but what change you find here, you know, H2O2 is reducing MnO4 minus from +7. This time you are not getting Mn2 plus. See this point. This time you are not getting Mn2 plus. This time what you are getting? Mn+4. Why? Why you are getting +4? Batao. Tell me why you are getting +4. Why you are not getting +2? Why you are not getting +2? Bolo. Why you are not getting +2? ठीक है? Because it is basic medium. In basic medium or slightly basic or neutral medium, MnO4 minus is reduced to MnO2, Mn+4. Is this clear? You can remember this also, oxidizing nature is there, so Mn+2 is converted into Mn+4. ठीक है? I2 is reduced to I minus. So you have to just see these conversions कि who is reduced to whom. ठीक है? Clear with this point? Who is reduced to whom? In NCERT they have written balanced equation. You can also balance these equations, no problem. Redox chapter balancing is there, do it. Okay, so that's it, I think. Is it okay? Now they are coming to one point, ki storage of H2O2. They are coming to next point, storage of H2O2. This is also problematic. What they are saying ki H2O2 decomposes. How it decomposes, bhai? It decomposes, we have already written, H2O2 will decompose to give water and half oxygen. ठीक है ना? So they will write 3-4 conditions. What conditions they will write? Exposure to light, decomposed. If you are in touch with alkali metal, decomposed. If you are in touch with dust particles, decomposed. So I am writing here one question which will cover everything. Which will cover everything. Like H2O2 decomposition is catalyzed by, first option is exposure to light. Exposure to light. Second option is alkali metal. Traces of alkali metal. contact with glass. Why they are saying contact with glass? Ki glass also contains alkali metals. Contains alkali metals. D part they will write dust particles. And the fourth point is there, all of these. So what is the answer? See, I have written all the points of storage just in one question. If you see this question, this topic done. Are you knowing this point? Jaldi se batao. So what is the answer? All of these. Dust particle, alkali metal, light, contact with glass. Glass is containing some alkali metals are present, traces. So like this. So now they will write. What they will write now? Batao. Now they will write ki so H2O2 is kept in wax lined glass container or glass bottle in dark. So see, light part over, wax lined, so not in contact with glass. So these are the point. And urea is added as an stabilizer. So urea is used as a stabilizer. They will ask you this question ki why we add urea in hydrogen peroxide? Why we add urea in hydrogen peroxide? Batao. Why we add urea in hydrogen peroxide? So it acts as an stabilizer. Clear with this point? So these points are written there. That's it. So now come to the next part. They are writing uses. Uses generally you see from NCERT on your own. But we will write few things. Quickly we can write. Uses, what they are writing? Ki it is used as a bleaching agent. It is used as a bleaching agent. Then they will say ki it is used as disinfectant. I told you na, antiseptic. Antiseptic, in form of antiseptic, it is called perhydrol. When you will go in market and you will ask for antiseptic, there will be written perhydrol. So H2O2 is also marketed as antiseptic by the name. It retards the decomposition, you can say. Urea prevents the decomposition. So perhydrol. Now you know few things about perhydrol. Can you tell me the volume strength of perhydrol? Quickly, everyone. Can you tell me the volume strength? Three points I want about perhydrol. 3 concentration terms I want perhydrol. Concentration of perhydrol in 3 ways. Jaldi batao. What you can say? Sir, 100 volume. Correct. 30%. Correct. 8.33 molar. Correct. Is it okay? That's it. Now many things are written there. Ki it is used in preparation of. So you will read it. You will read this from NCERT. I am telling you again. You will have to go and read it once. They will say preparation of perborate, percarbonate. Perborate, percarbonate. They will say quinones. They will quinone we made industrial preparation, you have seen. Pharmaceuticals, they will say. What name is written beside it? Can you check it? Pharmaceuticals, beside that we have something. So we'll have to read it. Then what main things are there? Ki pulp industry, bleaching agent in textile, pulp, many things are there. bleaching agent in textile, pulp, paper industry. And last point, we are interested in green chemistry. Green chemistry you will study in environmental chemistry chapter. Did you check it? So the name is there, cephalo. What is the name? Batao. Cephalosporin. So this name is there. ठीक है? Keep in mind. So in green chemistry, mainly we are interested in green chemistry. You will study in environmental chemistry chapter. There they will tell, array industry is producing so much waste. Delhi, Yamuna Pani very bad. They are putting the sewage pipelines in that Yamuna river. Foam is there. How to treat it? So this H2O2 is used in treatment of industrial effluents. ठीक है ना? This discharge, sewage and particles. One example I can write here only. They are writing here oxidation of oxides. Oxidation of cyanide, sorry. Oxidation of cyanide. So cyanide, if it is there, then it is oxidized. Clear? Pollution control. You can say pollution control. So one example I have written. You can see the rest. Clear with this point? So these are all the uses. These are all the uses. So is it clear to everyone? Done? ठीक है? That's it, I think. Now last point we are writing, and few things will be left. We will continue that in next class. ठीक है ना? Otherwise it will be more, although we can continue today also if you say, but we will see it once. So now they are comparing few properties of H2O2 and water. ठीक है ना? So what we have to keep in mass कि molar mass density, dipole moment of H2O2 is more. They are writing a dipole moment for H2O2 is around 2.1 and for water it is 1.85. ठीक है ना? So dipole moment is more for H2O2. This is important point. ठीक है ना? If dipole moment is more, you can say about boiling point also. Clear? ठीक है? Melting point, reverse order is there. Slightly less. They will write here 272 around, and here we know 273. ठीक है ना? Don't remember the data. Just see who is more, who is less. Strength of hydrogen bonding, they are saying water more. Dielectric constant in NCERT they have quoted the data around 78, 79, 80. Here we are having the data around 70. ठीक है ना? So like this we are having. So there is a comparison. All the points we have written at one point, H2O2 and H2O comparison. ठीक है? Is this clear? So we have studied many points today. So what do you want? We should continue now. ठीक है? The topics left are your heavy water. ठीक है ना? And heavy water 3-4 reactions are there, and then there is a hydrogen as a fuel. So maximum 10 points we are having. Maximum 10 points we are having. ठीक है? So these things are there. You should keep in mind. ठीक ना? Dipole moment of H2O2 is more, so you can say his boiling point is also more. ठीक है ना? And here we can say कि melting point slight gap is there. Dielectric constant is more. This is more important. These 3 points which I am saying na, these 3 points are more important. Clear? So it's time to eat. Huh? So we are having heavy water. ठीक है? So heavy water topic we will continue in next class. ठीक है? So it's already 1:15. Although we are on time only, but ठीक है, we'll start. We'll finish it in 5-10 minutes in the next class, and then we'll continue with our next chapter. That is your S block. ठीक है? Chances are there कि online holiday will be there. Chances are there, although they will confirm it later on only. ठीक है? So is it clear to everyone now? Done? Okay. ठीक है, fine. So Muharram is there, festival. ठीक है? So hope you have understood everything. Many points are there. We should keep these things in mind. ठीक है ना, स्मॉल स्मॉल पॉइंट्स आर देयर, कीप वॉचिंग द वीडियो, ठीक है ना, एंड व्हाट वी आर सेइंग ट्राई टू रिप्लाई एंड ऑल, ठीक है, ठीक है। तो चलो, नाउ यू कैन हैव योर लंच डिनर, व्हाट लंच यू विल हैव, डिनर एट नाइट, चलो, सो रिवाइज नाइसली, ठीक है। सी asking doubt, if I will get time I can reply to it, but it is not compulsory कि every time you will get the reply, ठीक है ना, although you can ask about the number if you are saying कि it will be distributed, but no चलो ठीक है, fine, so leave it, you can search it on the social media and you can ask me there, ठीक है, fine, so thanks everyone, read nicely, almost last class only, ठीक है, then we will start with the next chapter, ठीक है, चलो ठीक है, थैंक्स एवरीवन, बाय।